This is part 13 in the Creed 7B Teleprinter restoration series. In the previous video I fitted the solenoid, so that is now all the major components fitted to the chassis. There's just a few left to go and I've been cleaning and lubricating them, and I'll now fit those and explain what each one does as we go. So the first one I want to put on is the solenoid compensation device. So what this is for, it fulfills two functions. The first is it limits the throw of the solenoid. If you remember in an earlier video I said that the throw of the solenoid is actually very small, and this lever only moves just below the setting pin or in the center of the setting pin, so it only moves a few millimeters. But you may have noticed in the previous video that it was actually moving much further than that, and the reason for that is because this wasn't fitted. I also mentioned in the previous video that dirt in the armature of the solenoid could stop it working eventually, but without a device like this is a critical adjustment, so as soon as any dirt got down into the gap in the solenoid, then the machine would stop working because the adjustment would be thrown off. So in normal use the armature does not move over its entire range, so this is to prevent the solenoid going all the way from pole to pole. You don't really want that, it makes it too difficult to pull the armature back off again, and you also don't want this moving too far because eventually it will fatigue and fracture and snap off. So this is luckily fitted on a couple of pins. The adjustment is very critical on this, so it fits up in this position. I'll just bolt it into place and then explain how it works. Okay, so as I said, this fulfills two functions. The first thing is it limits the throw of the solenoid. So if I now move the solenoid, you would have noticed before that this lever was moving over quite a long range. If I now move it, it's moving over about a third of that range. In fact, it's only moving about 2 millimeters. Now I can see that it's not quite in the right place, it's very slightly low, but very close. Having said that, we're running this at slow speed, and from this point on, one thing to bear in mind when we make adjustments is this is normally running at quite a high speed, and because of that we have to take into account any odd behaviour or seeming inaccuracies in movement caused by that high speed. This is actually intended for that in part. So firstly, it now takes far less force to move this across, simply because the pole is not actually touching, the armature is not touching the pole pieces. So although it's closer to one pole than the other, which is what makes it stay there, it's not actually touching, so it's not clamped solidly onto the magnet. You probably know with magnets, if you put them together, they're quite hard to separate, but if they're even just a small distance apart, they're much easier to pull apart. And this of course allows much finer adjustment and control of the solenoid. The solenoid is adjustable. There's an adjuster screw back in this rear corner. The armature pivots right in the middle of the solenoid, and by allowing the solenoid to be moved, it pivots at this point here. Then what we can effectively do is change the way that the solenoid pivots around this point where it passes through this narrow slot, and that gives us extremely fine control over the movement of this part of the lever. We also have a very coarse adjustment over here as well should we need it. It looks to be in the right place. We'll check it when it's running at speed to make sure that it is hitting the center of the pin and clearing it when it needs to. So that's the first function of this plate. The other function is this compensation device. So there's a spring here that's mounted on two pins on this bar, which might seem kind of pointless, but this is kind of the storage space or place for this spring. What you'd normally do is attach one end of the spring to one of these two holes. That will then put spring tension pulling the solenoid one way or the other, and you can adjust the spring tension by winding this thumb wheel one way or the other. So if you wind it one way, it will stretch the spring, wind it the other way, it will shorten the spring. So you can effectively apply more or less force to the solenoid in one or other direction. And the reason for that is you have to bear in mind that when this was in use it was being fed with signals that could be coming from several miles away down very poor quality cables. So the differential signals or voltages going to the solenoid may well not have been as clean as they could have been, or as consistent as they could have been. So it might be that the solenoid had a tendency to go further one way than the other, or it was biased one way, in as much as there wasn't enough voltage pulling it one way and it wouldn't quite pull it across, or it wasn't going fast enough. That's what this is for. It allows you to bias the solenoid in one direction or the other. If you weren't getting clean operation, it was tending to stick in one side or was too slow. When I got this, the spring was already in this position. It wasn't ever attached to one of these, so either it wasn't needed, or somebody's taken it off for some reason and not put it back. Either way, I'm going to leave it where it is. We'll look at the machine in operation to see if it needs this to be fitted in one of these two positions and then adjusted. Okay, the next thing to go on is the automatic start and stop switch. This is a bit of an unusual design compared to the rest of the machine. The rest of the machine seems very careful, considered design. This seems a bit of an ad hoc add-on. What it does, it fulfills two functions. The first is that it allows the machine to be automatically started and stopped, either remotely or locally, and then it also fulfills a timer function to allow the machine to automatically stop if it's not being used for more than about a minute and a half. The way it works is it sits in this position, and the main shaft going across the machine, which will fit in a few minutes, drives this first gear. That in turn drives another gear and another gear, and the worm drives. So there's a very high ratio between the input gear and this final gear. This final gear, when this is turning, pulls this rod up, and on the end of this rod is a large weight, and that large weight is used to operate the start-stop switch. So when it's pulled up, it turns the switch one way, and when it's released, which I'll show you later on, it allows the weight to drop, and that turns the switch in the opposite direction. So what it's for is it allows for quick turn on when the machine is required, and then the machine will run for a while, and if no more characters are received or if no more keys are pressed, then after a while it will cause the machine to switch back off, kind of back into a standby mode. The reason it's desirable to have the machine continue running between characters is because it takes quite a long time, comparatively speaking, for the motor to start up, and it's way too slow to allow a byte to start being received, wait for the motor to start, and then successfully complete that sequence. There's no buffering in this as such, other than the one character in the selector drum. Really, the motor needs to be running when the machine starts receiving data, and to that end it has to be either started locally by somebody before data comes in, or there is a feature where it can be started remotely, but either way it has to be started before data starts coming in. Okay, so the way this is attached, there's a mounting bracket which will go in first. Okay, so I've got the bracket loosely bolted in place. I'm only fitting the front screw at this point because this will need careful alignment, because the bracket that bolts on here has the bearing for the main shaft at the top, so it will need to be fairly carefully aligned to make sure the bearing is running true, otherwise it will either bind up or it could damage the bearing. The next thing I need to do is fit the main shaft to this assembly. Okay, so this just fits in through this end. Then there's a washer, and a securing nut. I'll just get these tightened up. Okay, so I have that tightened, and the next thing is to fit the entire shaft back onto the machine. So firstly I have to fit this coupler onto the end of the motor shaft, Then I have to align everything and then drop the shaft into place. And make sure that it engages with these two gears. The little lever here engages in a slot in the end of the solenoid arm, and then I can fit the screws that hold the end bracket in place. Okay, so that's in place. The next thing we have to do is fit the weight, and this so it's a bit of a contrivance. It seems a bit strange compared to the rest of the machine, but it works, so that's all that's important. So that shaft goes down into the hole in the weight. Okay, now I did measure the position of this weight on this shaft. There's a little notch in the shaft. I measured the position between the top of the weight and that notch before I took it off. So again, I'm just going to adjust that off camera, and again, if you ever work on one of these and you start taking bits apart, it will save you a lot of time if you make notes of certain adjustments if you're going to destroy that adjustment by taking a part off. So I'll just get this adjusted and then get back on camera. Okay, so that's reattached, but I will adjust it again if it needs it later on. I don't know if it was correct to start with. So the next thing is a small bracket that goes around here that guides the weight as it rises and falls. So we'll get that bolted into place. Okay, so that's bolted in. Next thing is to fit this cover plate. So this is just to limit the throw of the switch and also to protect the weight from being pushed the wrong way. I may need to adjust the switch on this later, so I'm just going to put one screw in for now. And then the final screw to fit is the one that holds this bracket on the shaft to the main assembly. Okay, so that's everything in place. What I'll do now is lubricate the gears and check the adjustment of the switch, and then I'll get back on camera and we'll try and run up the motor for the first time. Okay, so the switch is fully installed. I've also fitted the two covers. As you can see, I've painted those and I've lubricated the gears, attached the coupling, and I've again gone through and checked the various settings to make sure that it's as close to setup as I can get it without running it. Some of the settings are actually dynamic. They don't work at low speed. In particular, the clutch is in two parts. There's a leading part of the clutch that is arrested by the selected character finger, and then there's a second part of the clutch that kind of follows on behind. And the reason for that is when the first part is stopped by the finger, the second part, which is attached to the print head, carries on and is slowed down over a few milliseconds to stop in the correct position, and that's to prevent it wearing out or the shock making the print head bounce back. But it doesn't mean that it won't run properly at low speed. If you try and turn it by hand, then it's not going to work as expected. It will stop in the wrong place. However, I have adjusted everything as best I can, so we're finally at the point where the only thing I can do now is to try and power it up. Now, it's obviously quite a risk. If I've got something wrong, there's a lot of energy stored in the motor when it's spinning. It does spin at high speed, as you've seen, and if something suddenly stops, then it's going to do quite a lot of damage, maybe strip gears and that sort of thing. So I have tried turning it quite a few times by hand, and it does seem to spin around. It doesn't seem to bind up anywhere, but you never can tell until you get it going at full speed exactly what's going to happen. So the first thing I'm going to do is test the motor, make sure it spins up. I've wound it to the point where, as far as I can tell, it's in the idle mode, and the solenoid is in the stop position. So In other words, none of this should really do very much. The only thing that should be operable is the timer switch, which is this. We have the switch at the bottom, which is what controls power to the motor. And what should happen now is this timer device should slowly wind up as the motor spins, and after a minute or so this weight should be raised fully up, and then the hook on the bottom of the weight should turn this switch off and the motor should stop. It will take a minute or so, so I'll start the motor, but I will fast forward while we're waiting for the switch to stop. But I will stop it if it makes any horrible noises or does anything weird. Okay, so we'll start the motor up, and fingers crossed we won't hear any horrible noises. Okay, so that's a promising sign. No horrible noises. It sounds quite good. I'm not quite sure how it sounds through the microphone on the camera, but certainly the timer's working. You saw the weight come up and it turned the switch off. Power's still applied. It's just that the switch has interrupted the power to the motor, and so the unit stopped. And as I said, that's just so that the motor doesn't run continuously once it's been started. Now, what it's done here is there's a small wheel at the top of this timer with small holes in it, and there's a little peg that sits in one of the holes, and as the wheel turns through, it's a very high gear ratio, as the wheel turns very slowly as the motor spins, it pulls the weight up, and when the solenoid comes out of the rest position, so that is when the first start bit is received, if the weight has started to come up, or if it's all the way at the top and it's stopped the motor, then what will happen is the solenoid will move across. There's a small lever at the back of this arrangement that will push this rod across, and it pushes the pin out of the captive wheel, and then the weight will drop down and it will take the switch, toggle with it, and start the motor. So I'll just try that. Now, what's also going to happen, of course, is that it's going to activate the receiver mechanism, so it might just come to a sudden stop if there's something wrong. If it's working to any degree, then we should see a complete cycle, or probably several cycles, depending on how quickly I can return the solenoid to its rest position. So what I'll do now is I'll move the solenoid. I'm doing this by hand, so obviously I can't do it quite as quickly as the incoming signals would do it, but we should see a complete cycle. This should drop down, and then I'll leave the timer to hopefully time out again. Okay, so again, that looks quite promising. The timer has worked again as it should, and we saw it go through a complete cycle when I first operated the solenoid. Now, this is the reason the motor has to be running before data comes in. You saw that it started up quite slowly. So normally the incoming data stream would have a start signal, or the machine would be started locally before data starts coming in. Otherwise it takes far too long for the mechanism to get up to speed and it would miss the incoming data. So what I'm going to do this time is I'm going to operate the solenoid. The machine will start up, and then once it's got up to speed, I'll operate the solenoid a few times just to try and run a few character cycles through the receiver mechanism and see what it actually does. Hopefully we won't get any horrible noises or sudden jams, and that will be a good indication that at least I've put it together right, and with a few adjustments it should be possible to get it working. So I'll start the motor up. It's gone through the first cycle, and this time when I operate the solenoid it should go through the cycle very quickly. And I don't know if you can see this on camera, but the operating fingers are of course stopping depending on when I pull the solenoid back across. When I pull the solenoid across, it's halfway through a cycle, so depending on when I pull the solenoid back, it's going to stop selecting ones and then continue to select zeros to the end of the cycle. That means that each time I do this, I'm going to get a different, or potentially a different character being selected, and we can see that on the selector drum. I don't know if it's selecting the correct character, but it is selecting a different one each time when different fingers are selected, so at least it does seem to be working as I would expect it to. I'll just do it a few more times, but if you can see the selector drum, you should see that it stops in a different place each time, depending on the combination that's received by the selector drum. Okay, so I'll turn the power off. So, as we can see, it does appear to be, at least on the face of it, behaving as we'd expect it to. It may need some more adjustments. I don't know if the hammer's correctly pressing the correct character pin. That's it for this video, but what I'm going to do next, and I will put this on the video if I can, is take some high-speed footage of the operation of the hammer and the print head to see if the clutch arrangement and the print head are stopping in the right place, and if the hammer's pressing just the correct pin. If you run it slowly, it presses 2 pins at once, but I suspect that's just because the machine does need to be running at speed for the clutch to work correctly. I'll try and post it if I can, but I don't really have a very good camera for high-speed footage, so it might not come out in good enough quality to post, but I will if I can. If not, I'll just do a follow-up video explaining what I found. After that, the next step will be to put something together so I can send it actual data and see if we can get the correct character to be selected. And then after that, I will restore the carriage, and following that I will restore the keyboard.